Hello everybody, this is Brad Duck reaching out to you, and today we're talking about something that was a real problem for me for a little while because I was having difficulty identifying where the bottlenecks were between my outbound ISP of a 1 gigabit connection and my internal network, which was actually up to 10 gigabits of speed. But I actually found out what the problem was. So that's what we're going to talk about. We're going to talk about true routers that can do a 1 gig bandwidth coming in and a 1 gig bandwidth going out in full rated performance level. Now that's an important detail, and I'll tell you why. When I started out in this configuration for a 1 gig ISP provided fiber optic connection, I was using a series Nighthawk Netgear platform, and it's a very good platform in general. You know, this AC1750 unit, this smart unit that I have here, the nice thing about this particular Netgear is that its ability to segment out traffic. But the problem I was having with it is I was only seeing 400, 500 megabit sustained transfer rates out and about when I did bandwidth tests. It could get up to a certain speed, but it wouldn't sustain it. It wasn't holding its own. And that's important because if you have a 1 gig fiber optic connection, like I have, you really want to get what you pay for, right? So what I mean by that is basically I have here, as you can see, a Metronet fiber optic transceiver set. It's right here. This is the fiber pair. And then it comes off of as another fiber pair, which goes up to my transceiver. This transceiver converts fiber optic connectivity into Cat5 connectivity, which goes into my front end router, which then in turns through a very specialized cable I made some time ago, which really works really well, goes up to the router. Now the router comes up to here, and if you look, this is a Nighthawk series, very nice specialized router, which kind of looks like a spaceship. But as you can see the back of it, it's a very traditional style back end, 2 USBs, 4 LANs, 1 external power off switch and reset and all of that. That comes down into here, which will provide basically a 1 gig pipe out and about. And I have it paired over here with my 4 lead points as actually one of my outputs, and it does a pretty good job actually. I'm impressed with it. Its performance is functional, does everything I want with it, and it's working pretty well. Now the problem that I initially had was that when I was using the fiber transceiver and it hit the OB right here, which would then go to my Linksys router, the first one, the Netgear router I had, that router, which is this one, I discovered kind of oddly that the onboard functional router was able to do 1 gig transfer rates, but the internal router, the one I had layered for functional protection, firewall, and so on, was not. It was averaging 400, 500 megabit. That's when I found out something very important. You see, the WAN connection is a 1 gig port, and they'll always negotiate at 1 gig ports. That's true. But the physical hardware inside this unit doesn't have the functionalized bandwidth to go over so many hundreds of megs of transfer rate, sustained-wise. In other words, the more the traffic, the more interaction, the less and less bandwidth you're going to get because the segmentation isn't handling it right or it doesn't have necessary caching on board to do that job well. Now you ask the question, okay, so what you're telling me is little tiny boxes like this don't have a lot of hardware resources to really take full advantage of a high-speed connection, even though the 2 uplinks are pretty small devices. That's because these devices only have to route one pathway from your initial source point. Your source point being the router itself, which is right there. Now, the router is the guy that's going to have to interface with all of this traffic, plus another master switch in another room in the lab, and handle and segment and load balance these workloads so that they will follow through out to the world and get to the necessary objectives. So the secret that's at that point stage is, okay, let's say, hey, I want to build a pfSense Linux-based firewall device, and you know what, that's fine. But if you put it on a device like this, like a small USB Raspberry Pi or something like that, because you want to be neat and sleek and small form factoring and so on, remember one key detail. When you do that, the physical hardware is an important detail. Now right here is my pfSense test router. Okay, this is a full-blown motherboard, and it has 3 functional server quality level NICs in it. A double set and 2 independents right here. Why are the 2 independents? Because I want inbound, I want outbound, and if I need to segment additional traffic, I can. And this guy has, 16 gigs of RAM, and he's proportionalized workload-wise is good. What is not good is when you use pfSense and use it on a baseline platform like this PC motherboard that only can go up to about 1 or 2 gigs, and you have PC NICs on board like this old style PCI NIC card right here, which is a classic low NTU baseline card, and they do basic traffic pretty well, considering that they're basically sitting in a platform that is fairly limited. And when you've got an onboard NIC on a motherboard like this right here, and you've got or a old style NIC card like this, they have limitations. So when you use old hardware or use reduced factor hardware like a Raspberry Pi, it's an effect. This is why small hubs and switches can't perform like the major size switches that you have out there, because there are additional resources built into here to handle all this segmented traffic you see here. And that, my dear friends, is a very important detail. So when you sit down and you want to build yourself something like this, make sure that you take into account one crucial detail. And that is basically make sure that your hardware is rated. Now that's what I'm going to talk about now. The Nighthawk series 8X series router. This guy right up here. Now, when I was testing this router versus its counterpart, the key detail about this guy is that he needed to reflect the same numbers that would be resulted by a single mode connection by its uploaded router. In other words, this to that, both pathways all have to be the same type of performance levels. When this router was incorporated into it and it started to see some basic traffic that was significant, it didn't and wouldn't be able to get beyond 400, maybe almost 500 megabit sustained traffic connectivity wise. But oddly enough, when I went to the up layer router that's provided by the ISP, it was a gig. So it's running at a gig, and this is not running at a gig. Even though they're negotiating at a gig connection, that definitely means nothing. When you get a 1 gig negotiation link on these ports that you see here, that just means that they handshake at a specific capacity. Now, that leads us to the next very important detail. So one of the other very important details is basically dealing with MTU. Now, if you remember my 10 gigabit network, why can't I get 10 gigabits out of my 10 gig network? It's because of the simple reality that you're not taking the time to properly configure the intercommunication between all the network interfaces at the proper configurations that they need to be set up by the manufacturer, as well as the MTU level. So every device out there is always defaulted to 1500 MTU. MTU is basically the way that it handles traffic loads and how much data can go through quickly. The higher it goes up, normally no higher than 9016 is a real good average. But when you're doing that, that means you're doing jumbo packets out there. That means really big packages that are moving a lot of data, not necessarily lots of files or individual components, but more of one file that's really big. And then you have, of course, the handshake of the protocols of the NICs that are out there. So if you have a 10 gigabit network and you're set to 916 out there, and then you interface with a 1 gig network, as you can see here that I have, then you also want to carry those MTU levels across the board. Now, understand, if you do that on your infrastructure switch, and this is a very good example of what I'm talking about, if you do that on these infrastructure switches, the infrastructure switch is the top of your pyramid for connectivity to the world. Now, that does not mean that it's the fastest of the structure, but it's the one that's one step to the outside world. Now, you may have, as I do, a pair of fibers running off here. They go to a 10 gig switch on the other side of the fence, which is perfectly fine. But even on that side, the port that it connects to is a 1 gig is configured as a 1 gigabit port, which is sitting on the residual of the rest of the ports, which are 10 gig. So when the servers are running on the 10 gig ports, they're actually stepping down to the 1 gig to get out to the rest of the house and do what's needed. Now, not everybody's like this, right? Usually what you have is a couple of boxes, maybe a couple of servers, 5 or 6 computers, and you also have appliances, Internet of Things devices, or SIP devices like you see here, an OBU series phone network device. These devices are small, baseline, they do certain things. Security systems are the same way. They're usually small pizza boxes in regards to how they're configured, but they don't usually get you to the point where you can start messing with the MTUs and so on. So you need to be careful when you start playing with MTUs, because stupid devices or devices you can't configure for higher MTUs may create backscattered traffic and cause your LEDs on your switches to blink a little bit more often than they normally are. But it's usually not bad. It's just something you want to be cautious about. Usually what I tell people is set your MTUs, isolate those workloads in their labs or in their locations, transition them that when you go out to the normal household infrastructure switch like this, make sure that you're starting to bring it down to a basic MTU 1500 so all the other devices can communicate. So with that being said, this is why I wanted to bring this up to you, because a lot of people will go out there and they'll get this really big pipe, 1 gig, 2 gig, 5 gig bandwidths using fiber optic pairs. But the capacity of what they do has to be configured all the way through your infrastructure to meet what you want to do. And that is important detail, because a lot of times that when you're dealing with this footprint, the big mistake is made right at the top of the system. First, always make sure that your 1 gig pipe to your router gig pipe connect with a laptop and run a speed test to make sure it's giving you the speed that you need. Do 3 or 4 or 6 sites and average out the total bandwidths between them. If you're about a gig or a 2 gig or whatever you're getting, that will give you everything you need to know. Secondly, make sure you repeat the same set of tests on your localized router. Right after you've done it, connect up the same speed test device and everything and run the test. Do not use Wi-Fi. Always use cable feeds. And when you do this test, connect the laptop to the device directly first. Then repeat the test again. Again, that test is run the speed test 3 to 6 times, average out your totals between them, and then eventually step down to your master infrastructure switch and repeat the test. This is how you're going to know that you've got the bandwidth that you need, and this will also tell you if maybe your router is acting up. I can tell you true 1 gig up, 1 gig down routers is a recent development, which means there's a pretty large number of routers out there that are strictly built for TX100, 2, 3, 4, 500 megabit bandwidths. That's it. They were never going to get beyond that. And when you start putting out some real demand is when you start saying, why am I not getting what I'm paying for? So with that being said, I'm going to go ahead and say that's it. We've done a pretty good job here in regards to explaining the 1, 2, 3s. I had to go through this. It was kind of painful. Drag the ISP guys in here, swap out routers and do all that kind of stuff. And then I developed this 1, 2, 3 process to help me understand a little bit better how this needs to be more optimized to give you what you're wanting. So with that, if you have any questions, please feel free to send me a text message or something like that through YouTube. I'll try to answer it the best I can, and I hope you guys have fun, enjoy, and God bless. Take care.